Qualcomm's acquisition of the Arduino created a new vibe. AI and signal processing on the Uno Q. Qualcomm buys Arduino, the Dragon Wing MPU and STMicro MCU are the new created the largest to create the largest board and Arduino Uno Q with developed support for Linux OS and a vibe-coded AI solution. What you will learn. Arduino is being acquired by the Qualcomm subject to a regulatory approval for its close to the sun. Qualcomm Arduino introduces a new Uno form factor board, the Arduino Uno, as which features both a STM32 MCU and Qualcomm Dragon Wing MPU. The STM32 MCU coupled with the Qualcomm Dragon Wing's AI acceleration quad-core CPU, as well as GPU and dual ISP support turn a Uno Q into a compact, cost-effective platform for the robotic, IoT, and edge AI. San Diego-based Qualcomm today announced that they are acquiring the Arduino, the Italian company that are owned among makers and products developed for their lines of ready-to-use open-source control and processor board. More importantly, though, an open-source company philosophy that provides a rich set of coding libraries and applications that work seamlessly within the Arduino IDE integrated development environment. So, Qualcomm has expressed assurance that Arduino will run business as usual and are free to choose the devices that go into future Arduino hardware designs. Obviously, born out of the new alliance, Arduino has gone public with a new Uno form factor board, the Arduino Uno Q Figure 1 Banana for a scale as an exclusive to electronic design. The Qualcomm Figure 1 is Qualcomm new Arduino Uno Q board, Banana 4 scale. The Arduino Uno Q combines high-performance computing and precise real-time control in one compact board. At its heart is the Qualcomm Dragon Wing QRV 2210 microprocessor MPU, delivering AI acceleration, graphics, and connectivity alongside a real-time STM32U5 and 85. The microcontroller MCU, the unique hybrid design makes Uno Q has a versatile as it is powerful from running Linux applications to handle robotics tasks, or with the simplicity that Arduino for the Qualcomm Arduino. So let's start with the familiar and then work toward the Linux and AI and vibe coding that are now on the table. Arduino Uno Q board overview. The Uno Q board is available in the standard Uno family form factor of 68.85 times 53.33 for 34 millimeter. It uses their family a familiar connect and signal arrangement figure 2, landing compatibility with many legacy Arduino Shield, aka dollar cards or the mezzanine card on board. Figure 2, top side of Arduino Uno Q is showing a legacy Uno form factor and connectors. Note that the STM32 MCU's GPIO does run at 3.3 volt, is 5 volt tolerant on both pins, and is both CMOS and TTL compatible. For those designs requiring true 5 volt TTL I/O, a 5 volt adapter shield is available from such sources as Smartphone Electronics. The Uno Q's 5V. The input is via USB-C connector at 3 ampere, or it can be supplied via a separate plus 5 volt input pin. The board features similar to the Arduino R4 Wi-Fi covered by electronic design include 4x RGB user controllable LEDs, 8x13 blue LED matrix, 1 times the key connector voltage 3.3 I2C, 1x user pushbutton, JCTL MPU remote debug connector. Interfaces native to the onboard microcontroller MCU include I2C, I3C, SPIN, PWM, and CAN, UART, PSSI, and GPIO, JTAG, ADC. The backside of the UNO Q, Figure 3, does have a set of the connector for the additional I/O and high-speed interfaces, such as cameras, display, audio, and etc., supported by the MCU. 3. Both sides of Arduino UNO Q showing the new high-speed connectors and the Dragon Wing MPU. SD microcontroller. The top side of the UNO Q has a SD micro STM32U 585 microcontroller, which features the ARM Cortex M33 running at up to 160 MHz, delivering up to 240 DPIMS MIPS with 1.5 bps per megahertz. Drystone 2.1 benchmarking. Figure 4. The block diagram of the STM32 MCU as used on the Arduino UNO Q. For memory UNO Q, the MCU has 2 MB flash memory with ECC. Arranged in 2 banks, the facility read while write and includes 500 to 12 kilobytes with 100 kilocycles of write lifetime. The MCU also packed 786 kilobyte SRAM with ECC or 722 kilobyte SRAM, including up to 322 kilobyte SRAM with ECC on. Additionally, the STM has external memory interfaces support SRAM, PSRAM, NOR NRAM, and FRAM memories up to the OctoSPI memory interfaces. The of concern to any legacy Arduino Uno aficionado, the MCU has up to 136 fast I/O with the Intel capabilities, most of which are the 5-volt torrent up to 14 iOS with the independent supply down to the 1.08 volt. How? These are connected to the UNO family connector. Blueprint is not available at time of this writing. Each of the MCU's GPIO pins can be configured by the software as output, push-pull or open drain as input, with or without a probe or pull-down, or as prefers alternate function. Most of the GPIO pins are shared with the digital analog alternative functions. After reset, all GPIOs are in the analog mode to reduce power consumption. The IO's alternative function configures can be locked if needed following a specific sequence to avoid spurious writing to the IO's registers. Given the presence of the X times 13 blue LED matrix on the UNO Q board, the GPIO clearly has sufficient source and sink capability for that task. All IOs are CMOS and TTL compliant, so no their configuration required. Their characteristics over more than a straight CMOS or TTL parameters. Regarding timers, the MCU features two 16-bit advanced board control timers, 4 32-bit and 5 16-bit, and 4 more lower 16-bit available in the top stop mode, 2 SysTick, and 2 watchdog timer. A real-time clock RTC is available on a chip with hardware calendars and calibration. Worth of note is the integrated CAN FD controller and the 2 SDMMT interface and a multifunction digital filter, 6 filters, an audio digital filter, the sound activity detection, and preparation synchronous slave interfaces. PSSI is embedded in silicon. The MCU 16 and 4-channel DMA controllers are also functional in stop mode. On the graphic display side, a Chrome Art Accelerator DMA2D has been integrated to fully enhance the graphics content creation. Video embed is supported with a digital camera interface's mathematical coprocessor. A real-time inverse kinematic computation and foundry robotics applications are for motor controller, metering and signal processing, and many other applications. The coprocessor provides hardware acceleration of certain mathematical functions, notably trigonometry. This speeds up the calculation of these functions compared to the software implementation. The STM32 field mathematical accelerator MAC performs mathematics operational vectors. It comprises a MAC multiplier accumulator unit together with address generation logic that allows it to index vectors, element HAL, and local memory. The unit includes support for circular buffers on the input and output that makes it possible to implement digital features, both finite and infinite impulse. The responding features can be done. On the analog side, up to 22 capacitive sensing channels support touch key, linear, and rotary touch sensors. Original analog prefers with an independent analog power supply include 14-bit ADC 2.5 MSPS with hardware oversampling, 12-bit ADC 2.5 MSPS with hardware oversampling, autonomous in the stop-to mode. 212-bit DAC is low power sample and hold, 2 operation amplifiers with built-in PGA, 2 ultra-low power compilers. The MCU runs a real-time operating system RTOS with Arduino Core on a Jaffer OS. Microprocessor unit. The new added capability of the Arduino Uno Q is largely due to the presence of a second processing unit. The Qualcomm Dragon Wing QRB2210 Figure 5, which provides AI acceleration, a quad-core CPU, and Arduino GPU and dual ISP support. 5 block diagram on a Dragon Wing MPU as used on the Arduino Uno Q. More specifically, the Dragon Wing features quad-core ARMs, Cortex A53 2.0 GHz, Arduino GPU 3D graphics accelerator, 2x ISP, 13 MP per 13 MP or 25 MP at 30 FPS. The RAM 2 GB LPDDR4 4 GB variant available year-end 2025. Storage 16 GB eMMC 32 the GB variant available year-end 2025. Connectivity Wi-Fi 5 2.4 and 5 GB with onboard antenna. Bluetooth 5.1 with onboard antenna. Camera. The USB camera support 2 times BP CSI pins in a JBedia header. Display. Video output support via USB-C and BP CSI pins on JBedia header. Audio microphone in, headphone out, line out, JMISC, MPU OS. The Dragon Wing runs Linux Debian OS with upstream support and enables the new Arduino IDE to run natively on it without a need for an external computer system. IDE. The Arduino Uno Q uses the entire new IDE that unifies the journey across the real-time Linux, Python, and AI, though the details are sparse at press time, just as the Arduino Legacy IDE. A rich library example figure 6 is provided on an application basis. 6 screenshots of the new Arduino Uno Q. The vibe coding is also rumors capability in the new IDE where programs are generated by the IDE LLMs IDE for AI for the Uno Q based upon text prompted by the allegedly inexperienced users, and the hands-on experience developed. The possibility does exist for increased productivity and shorter development time. The new IDE is available for download. Summary: the Arduino Uno Q is a 2 GB of the RAM and 16 the eMMC is available for order immediately. Shipping starting October 25, 2025. It's priced at the 39 euro or the 44 US dollars. So the Adreno Uno Q with the 4 GB of RAM and the 32 GB eMMC is available for order in November 2025, ships by the YE 2025 and year-end 2025 and is priced at 53 euro or $59. Although for our leaders convenient, the Arduino Q user manual is available for download here. The Arduino Uno Q has been requested from the Arduino, which will enable electronic design to do some tire kicking to share with the leaders. Space and time constraint limit more details, so the data sheet for the STM32 and the drawing gun wing are available to readers. Convenient to download here. As always, when embarking on new design and ensuring component available and download the latest information from the respective manufacturer, more data on Arduino Q will be added here as it becomes available. And the non-linearity blog live the first and the third Monday and the Thursday of the month. To make sure that you don't miss the latest edition, the new articles or breaking new coverage, please subscribe here. Okay, thank you. Next one is our article is NVIDIA reportedly signs another blockbuster AI supply deal. This time, the Elon Musk XAI investor will support to any $1 billion Colossus 2 Memphis project. NVIDIA chips in the while Musk swept the turbine. Okay, Elon Musk AI venture XAI is preparing to raise roughly $20 billion through a combination of equity and debt, and with the NVIDIA playing a central role in the funding structure and chip supply. According to the Bloomberg, the funds are being split within the $7 and $8 billion and a new equity and as much as $12 billion in debt, routed through a special purpose vehicle that purchased NVIDIA's GPU and leases them out to XAI. NVIDIA itself is believed to be investing up to $2 billion into the equity portion, according to the Bloomberg sources. The arrangement effectively finances the purchases of the NVIDIA's own hardware, while ensuring the XAI secured priority access to GPU during a period of tightening supply. It also gives NVIDIA full foothold in one of the most aggressive AI training deployments in the United States. The chips are embarked for Colossus 2 XAI's 100 megawatt Memphis site, which came online earlier this year. Musk has planned to double the site GPU count to 100,000. In September, Musk publicly denied the rumor that claimed XAI was raising $10 billion at a $200 billion valuation, taking 2x to say fake news. XAI is raising any capital right now. So the deal now described by Bloomberg is larger, more complex, and more tightly bound to NVIDIA. Reuters confirmed that the chip would be used at XAI's Memphis site, while others believe this to be continuation of the AI industry's crowdfunding. As for the chips, these may arrive before the permanent grid infrastructure is in place. XAI is unknown to have attuned to a large-scale turbine deployment to meet power needs during scrutiny from the regulators and the environmental groups, with many claiming the company has installed and operated a methane gas turbine without a full permission, a claim the company has disputed. According to the Southern Environmental Law Center (SERC), a workers critic of the project state that a second Memphis site is under evaluation with dozens more turbines planned. The second build out could host between 40 and 90 methane gas turbines, generating up to 1.5 gigawatts of electricity, which is far more than a closest to is expected to consume in its initial phase. Documentary review the SERC suggested both sites are part of the broader strategy to sidestep grid constrained by producing power on site, regardless of environmental or permitting concerns. And the financing closes at the site Bloomberg described. xAI will have secured not just the GPUs needed to train at scale, but also autonomy to run them on its own term. Okay, next one is NVIDIA and Intel could win in AI PC war with this secret weapon. Forget integrated graphics. The real power of this alliance lies in memory architecture. If you haven't heard, NVIDIA investing $5 billion in Intel. According to the NVIDIA CEO Jensen Huang, this exciting NVIDIA and Intel alliance will create an Intel x86 SoC that integrated NVIDIA graphic chiplets, fusing the world's best CPU and GPU. This could be the injection Intel needs to break out of its funk and course correct its downward trajectory. But this fusion isn't about, say, improving the Intel Arc integrated graphics. It's actually a step toward AI PC dominance. NVIDIA GPUs has long been the best hardware for local AI workloads, but they are limited by VRAM. With Intel's help, NVIDIA could finally solve that bottleneck by developing the same power that Apple has been wielding. I'm talking about unified memory. Picture a modern tech desktop PC that fitted with an Intel CPU and NVIDIA GPU. The Intel CPU relies on the RAM on the motherboard, while the NVIDIA GPU relies on the VRAM into itself. To communicate, they need to move data between RAM and VRAM, and that's slow. For PC gaming, this isn't a major problem. For example, as an NVIDIA GeForce RTX 5080 has 16 GB of VRAM and that's plenty for games, but for GPU compute tasks, VRAM is essentially the data workplace, so more VRAM is better. This is critical for local LLMs and other local AI tasks, but also for any CUDA workloads on NVIDIA GPUs. In other words, if you want to run long local LLM on your desktop, it has to fit into your GPU's memory. Got a desktop PC with a whopping 128 GB of RAM, it does not matter. If your GPU only has 16 GB of VRAM, that's your limit. And that just isn't enough for next-gen AI. Yes, NVIDIA has the most mature GPU computer system and the fastest, most powerful GPUs in the world. But to take advantage for them for memory-hungry tasks, you need a lot of VRAM. At a certain point, it's no longer about the GPU speed, it's about any gigabytes of data you can feed into GPU memory for direct speed access. Enter unified memory. You can think of unified memory as a single pool of the RAM that's shared between the CPU and GPU. With unified memory, communication between CPU and GPU is faster, since data doesn't need to be constantly moved to RAM to VRAM and vice versa. It also expands how much RAM and GPU has access to. Now let me be clear. Intel and NVIDIA have not announced the unified memory, not yet anyway, but they announced something close The integration of NVIDIA GPU chiplet on the same SoC package as an Intel CPU connected with the NVLink and its data center product. NVLink C2C allows the CPU and GPU to share memory. Sound familiar? The AMD, Sound, and Qualcomm all have shared memory already. On the Mac side, Apple Silicon is a poster child for unified memory. You can buy a MacBook with 128GB and unified memory, and that memory can be used by both the MacBook CPU and GPU. Meanwhile, the NVIDIA GPU RTX 5090 had 32GB of VRAM for AI workloads where memory capacity is bottlenecked. A MacBook can outperform a beefy desktop PC with a high-end Intel CPU and RTX 5090, even though the NVIDIA's RTX GPU is much faster than Apple's. You also have AMD's APU architecture, which offers system memory shared between CPU and GPU. Qualcomm Snapdragon X, which has unified memory like Apple, and Intel's Luna Lake platform, which has unpackaged memory shared between CPU and GPU. AMD Ryzen AI Max Plus supports up to a maximum of 128GB of memory, but many AI tools and GPU compute workloads are designed for CUDA and NVIDIA software platform. Without CUDA, the AMD system may not be compatible with the tools that you want to run, and those integrated Qualcomm and Intel GPU just aren't that fast. Right now, only AMD and Apple are truly in the running. Though they have a unified memory, Apple, AMD, Qualcomm, and Intel don't have the powerful GPUs of NVIDIA or the mature CUDA platform that makes NVIDIA stand out for GPU computing tasks. Yet, while CUDA is the de facto standard, the industry is trying to change this with the technologies with the Windows ML. Competitors are chipping away at NVIDIA lead here. To pull ahead again, NVIDIA needs to find a way for each GPU to access the system main pool of memory, just like Apple and AMD and Qualcomm already allow on their SoCs. It doesn't really matter if the NVIDIA has our most powerful GPU compute.